Alright, time for another draftphysics.com video presentation. So I guess we'll put this in the series of videos regarding the clay experiment mostly. I suppose Ian Gosling is going to talk a little bit about something else, but the real challenge was to see how much energy something dropped from 4 times the height in gravity has. They say it has 4 times the energy because it fell 4 units of gravity. Now, I've pointed out that it's only in the gravity twice as long, which is kind of a key thing to recognize, but they really won't pay any attention to how gravity works. 9.8 meters per 1 second. Alright, that doesn't mean anything to them. Alright, so we've been playing with clay and springs. So he did the clay experiment correctly from the correct heights, and it came out perfectly demonstrating what I think is reasonable. 2 times 1 equals 1 times 2. But Ian says that can't be right, because 1 times 2 equals 4. And that's what he's doing. So he's basically saying 1 times 1 is, 1 plus 1 is 4, essentially. And so I've explained that springs work a certain way. So, okay, the clay experiment came out perfectly, confirming momentum as the mechanism, and he wouldn't show that experiment. So I can't show it to you because he wouldn't show the experiment. He would talk about it, but he wouldn't show it. So they haven't debunked it in any way. They haven't pointed out how, no, this stuff is the wrong material and it doesn't work, and no, nothing. All right, so that's just part of their integrity, is that they show you the experiments where they rig it to work, and they don't show you the ones where it doesn't work. Okay. So the spring experiment is another way to do it, right? You put a spring down here and you see how much it compresses a spring. So the versions of that, he had to create some little rickety thing that I pointed out in videos that he pushes instead of a decent way to get the impulse energy. But the simpler argument is this simple argument, that if I put something on a scale, I can compress the scale twice as much, and I don't have to do 4 times the work. There's just no chance that it's 4 times the work. So, I mean, I've illustrated this over and over. So I can get 1 spring compression, 1x the spring compression, by just putting an object on the spring. And then when I put the second object on, it doubles the compression of the spring, right? So you all know that, right? I put 50 pounds on a scale, it goes down a certain amount, and it goes down twice as much if I put 100. So if I put another 50, I guess get another unit. Okay, that's all. Scales are marked exactly as the spring compresses. The little markings on the scale just represent how much the spring's compressing. So obviously, it's obvious that 200 pounds is just twice the weight. It's not 4 times the weight. There's not some special 4 timesness happening. So his theory is that I use the same work to put both objects on. So I put 1 object on, I get this much compression. I put the second object on, I get 3x the energy, but there's only twice the compression. It's only 2x, okay, the compression of the spring. So 2x equals 4x somehow. And more importantly, if I just lift this one off, or I lift this one off, I can remove 75% of the energy. So I only remove 50% of the weight. I take off the 50 pounds off the scale, and now the spring only has 25% of the energy left. It can't make any sense to anybody reasonable, right? I mean, 1 plus 1 does not equal 4. All right, so we've been over and over this. So he's going to talk about some other things, but just figure out, point out what he's evading as arguments before we get to the arguments he's playing with. So he's going to rag because I said it was 1 to 3.5 instead of saying 1 to 4 or some kind of crap like that, but whatever. That's only part of the video I watched. So we'll see. In my opinion, he's always way off the subject. Always.
In the interest of fairness, I wanted to correct my misrepresentation of my experiment that clearly demonstrated that double the extension of a spring would produce quadruple the energy.
Quadruple the energy? So obviously it didn't do that. I mean, it's short. I mean, it just didn't come up with the right numbers. But go ahead. And I already pointed out how everything you did in the experiment, I mean, even to the case of still using string, okay, are flaws. They're introduced variables that don't serve a very good purpose. There's no reason to introduce something that can create a variable. Like your little pretend I know exactly how much friction to put on the wheel. You do?
These numbers, for the single extension, I had 1.4, 1.4, 1.5, 1.4.
Now, why are there differences anyway? I mean, the differences seem rather significant, frankly. 10%, 15%. Why are you getting variations that broad? You know, it's a big difference.
Double extension, I had 4 1/4, 3 3/4, 3 3/4, 3 3/4, 4 1/4, and 4 1/2. The ideal result between 1 and 4, the ideal result would be a difference of 3. Well, if we take the 1 1/4 and the 3 3/4, I was achieving 2 1/2.
1 1/4 and 3 3/4. So 1 1/4 would be 5. So you should be getting a 5, okay? And you didn't. You got a 3 and a 3/4. So the difference is the difference between 5 and 3 3/4, which is a full 1 1/4, which, in my opinion, is a monstrous miss.
But 2 1/2 is a lot better than an ambiguous halfway between 1 and 4, isn't it?
Okay, 5 and 3 1/4. That's what you should have got, right? 4 times 1 1/4 is 5. You got 3 3/4. Okay, that's not very close. So I don't know what you're doing here, but it didn't work on me. Okay, maybe it'll work on somebody else, but it didn't work on me.
Just 3. I'm sure that was an honest oversight on your behalf, Gary, but I needed to correct that.
I don't know if I oversighted any. I just don't think that 3 3/4 is a very good representation of 5. No, I really don't.
We'll have things I say or do misrepresented in that fashion. And also, I'll put a link. You did mention that the friction would have been a problem for the
Yeah, duh.
double extension.
What do you know about friction? I mean, I just don't know where you became any kind of expert on friction. And I don't think you even know the distinction between static friction and linear friction.
Being that the friction would have reduced as the wheel turned faster. That is known to be incorrect in engine.
I'm sorry. There's no fucking way you know that. There's no testing, okay? Friction goes down, okay, for every bearing I've ever heard of. I mean, a hard drive disk. The friction goes way down as you increase the RPMs. You can hear it, for fuck's sake. You can hear the thing spin up. Fuck, what a pile of shit. He'll put a link to absolute crap, I'm sure. And it's, the fact is this application of, there's absolutely nobody's ever studied in any, you can't do it any realistic way because it depends on whether you're using friction based on pressure with hard things or whether you're using friction with soft things. I mean, that's silly. You're such a silly person.
I've got books where they talk about that.
Yeah, right. In what, 1743?
And also, I've proved that incorrect with an experiment I did on the treadmill, demonstrating.
The treadmill experiments were priceless. I mean, frankly, the idiot actually put a scale on the treadmill and moved it sideways. Instead of doing this, moving something across a scale to demonstrate that it weighs less the faster you move it, he put the whole scale on a treadmill and moved it sideways. Yeah. It's just, I didn't think the video was going to be this funny. Oh, God.
As the speed is increased, the friction force stays the same. And I'll put a link to that.
Oh, it's just a lie. I mean, I almost feel like doing the link now, right? I mean, the friction force is increased with speed, as he's saying. Right? When there's absolutely no such thing. Oh, where is it? Test for friction and velocity. I don't see any link. So I'll have to go find that, I guess. Oh, this is it. They put YouTube turned it into a video link. Oh. Yeah, it made it special. This is his fucking video. What the fuck? What is this crap? Your video is going to prove anything? No fucking chance. Alright, well, we're not playing one of your videos. What a fucking asshole. Anyway, let's continue.
For anybody of your viewers who might be interested in seeing the truth. Now.
So the truth is that the experiment he hid with the simplest mechanism you could create, which is just dropping weights on a material that deforms permanently, semi-permanently at least, realistically permanently, for the purposes of the experiment permanently, he hid that. We don't get to see it. I don't get to challenge them to explain how it's way off. What factor, what variable made that one way off? But he does some wacky wheel experiment, right, with string and a spring and friction device that he created. Oh yeah, we're supposed to believe that. And the results sucked anyway. 5 versus 3 3/4. That's the same answer. No, it really isn't.
Now we're going to talk about one of your favourite examples. We've got a one mass. Yeah, going along.
You're right. And this experiment is done a million times, really. I mean, there's lots and lots of examples. Actually, the South Africans are very good at doing it, with the old ticker tape and everything. And it's just this is the slam dunk argument for how physics is just bullshit, because they just overtly lie about what happens in the experiment. I mean, it's just obvious. They say, oh, there's all kinds of crushing and crashing and deformation and all kinds of things happen. When you can watch the experiment, nothing happens. Okay, the mass sticks to the other mass quite well, and all of the momentum just about is conserved. Yet they say without using any of the velocity of the object, it deformed things and it shot things into space and it made all kinds of terrible sounds and it made all kinds of heat and did all kinds of stuff, and it didn't use any of its momentum. So it's like a magic, the magic Kennedy bullet. They could have a whole new conspiracy theory about Kennedy, because apparently the bullet doesn't have to slow down to make noises and to shoot things into space. The bullet can still keep all of its momentum. It's just too silly.
And velocity. We drop a one mass on it, they combine, move off. There's now 2 mass at 5 velocity. I'm going to suggest we make this completely no losses at all. No friction, no windage loss.
Well, there's obviously no loss because you're introducing another force. So you have a force going this way, a positive momentum, and the other one has a positive momentum. You're adding more energy to the system. You're not subtracting energy. When you're adding the mass, it's coming with its own momentum. So you have a little extra momentum even to piss away. That's the beauty of the drop it experiment, is that you're gaining some extra energy in the experiment. If you just bang, the 5 into the 5 with and have it stick with Velcro or something, you're not getting any extra energy. So you don't any noise you make, any sound you make absolutely has to come out of the energy of the object hitting it. But the fact is, in both experiments, 99% of the momentum is conserved. And yet, they say they lost half the magical energy. Just like the 3/4 thing. I lift 50 pounds. I have 100 pounds on the scale. I lift off 50 pounds. I lost 3/4 of the energy.
No impact, loss, no sound, no vibration, no heat, nothing. So we would have a complete conservation, as you say, of the momentum. Because here we've got 1 mass times 10v.
I just can't wait to hear how he's going to explain that. That makes perfectly good sense to me. That's right, you have all of the momentum, but you lost half of the energy. Because energy's, you can destroy it and such.
10 momentum. And a 2 mass times 5v is still a 10 momentum as the outcome. You also say that this 10 momentum can be represented as an energy unit. So let's say we call this 10 energy units, 10e. And the output is still 10e. 10 units of energy.
Momentum, yes. Momentum is conserved. The stuff Descartes, Galileo, and Newton all believed in is conserved. Yes.
On the result, as the 10 units of energy this mass has as it's moving along. Now I'm going to prove to you, using pure logic reason, and we'll see if you can follow, because you're the big promoter.
Well, whatever. Right? Yeah. So he's going to explain how, 1 times 2 doesn't equal 2 times 1.
Saying that we, the whole human race, is a waste of brain, is a brain mush, is nothing, Well, let's see if you can...
You are. You're all a bunch of wooey, fabulist fakers living in a very fake world of fake identities. You talk like you don't do a certain thing, and then as soon as the doors are closed, you do that thing. You're all just so full of lies and shit.
It's your brain mush. It's, of course, hypocrisy of the highest degree. So anyway, we've got 10 momentum, and we've got 10 momentum on the output. Is that right?
I mean, you've been over it 17 times now. Could you just get to your big surprise? Watch me pull a pigeon out of my, douchebag.
Mass times 10v, 2 mass times 5, yeah. 10 units of energy coming in, and 10 units of energy going out. According to your momentum theory, right?
Yes, proven fact, blah, blah, blah.
Now, how can that be? When this mass is dropped on and they combine, it's suddenly turning direction, isn't it? And is then accelerated to the right.
How is it accelerated to the right? What mechanism accelerate? If it was clay and you dropped it, well, you could say, yeah, some of the clays, it gets a velocity sideways. But how does a hunk of steel accelerate to the right? You have an example of where I drop the wrecking ball straight down and it accelerates to the right? The Earth accelerated to the right? I mean, where's your example of straight down being acceleration to the right? So this is his simple example. So okay, go ahead and contrive an experiment where what you say happens. I drop something straight down and it accelerates to the right. Show me that.
How does it do that, Gary?
Oh, he's talking about this mass. Because it applies friction to the other object and it's just like banging into it. All of the energy in the other object is shooting right into the object. Obviously, you're sitting there saying it's 10 momentums, right? You're ignoring the velocity. So we've now doubled the mass, and so now it's like bread. Okay, so I can just use the bread and butter example, right? This will be simple enough, right? It's just bread and butter. You have butter as the velocity and bread is the mass. And so all you're doing is saying I have a certain amount of butter and I have a certain amount of bread to start with. So I have 1 slice of bread to start and I have 1 lob of butter. And so obviously the butter is thick because there's only 1 piece of bread. And all I'm going to do now is drop another piece of bread down. So what happens to the butter? Well, I put the butter on half as thick. So I'm going 5 miles an hour. So obviously that's how it happened. It's like dropping ink into water or anything else. It's going to spread into the other object. So when the one object sticks to the other object has to accept the energy. And clearly the one object gave away its money. It had $10 worth of velocity. It gave away $5. Is that too complicated? So it left with $5 of velocity, because it cut its velocity in half. Oh, I didn't think it'd be this stupid.
What magic dust, what fairy dust makes it accelerate to the right?
So there's no fairy dust that makes it accelerate. It attaches to the thing by the Velcro of atomic adhesion, or however you want to describe it. Also, gravity's constant force pushing it down onto the other object. But things tend to stick. So sticking things is really easy, and it sticks really easy. And once you've stuck it, it now has to carry that extra mass. Not complicated at all.
Energy makes it do that. There must be an energy cost, mustn't there, Gary? To move any mass takes energy.
Right, and we saw that it takes energy in the sense that it's the mass, you fucking idiot. It's now 2 mass. Okay, so I didn't lose any energy. It's just spread over 2 masses now. Oh, I mean, there's just no point talking to morons. It didn't lose any energy because it's the same amount of energy. So obviously it didn't lose any because it's the same amount. You're saying, right, you drew it right here, 10. It didn't lose any because it just spread what it had over the bigger surface. There's no other way to say it. I mean, the bread analogy is clear enough.
What?
The money analogy is clear enough.
So where's the energy come from, Gary? Because look.
You have 2 $5 bills now instead of a $10 bill. All you did was take your $10 bill, you cut it in half, you gave one object half, the other object half. You still have all your money.
The outcome says we've got 10 units of energy, and 10 units of energy coming in, and 10 units of energy going out. Where's the energy come from to accelerate this mass to the right?
It comes from the fact that the velocity is half, and obviously the mass has now been doubled. So doubling the mass, the energy was spread over the twice as much mass. There's nothing broken here. Alright, so whatever. This is just contriving, this is just, I'm going to desperately come up with some word problem, okay, to make this somehow a paradox when there's nothing complicated about it. Again, if you just drew it as the train hitting the other train, it just becomes obvious. They just become connected, all right, and the reduction in the velocity is compensated by the doubling of the mass.
Using your theory, the momentum's conserved. Where's the energy coming from? Where's it been lost to accelerate this mass?
I didn't have to lose energy to accelerate the mass because the end product has the mass included in it. Everything I gave to the other object, I still have, retard. Everything we did to accelerate the other mass is still in the object you're measuring. The energy is still going in the same direction. How can I lose it if it's going in the same direction? I have energy. I give it to another object, okay, but it's going in the same direction. How can I lose the energy? I mean, it's like saying I put a laser beam through a beam splitter and turn it into 2 laser beams going exactly in the same direction. I haven't changed anything. It's the same amount of photons. Whatever. Pathetic.
It hasn't, has it? It's been accelerated for free, according to your theory.
So let's just understand their theory. Their theory is it lost half the energy of the original 5-mass car was lost, yet all of the momentum was conserved. So all of the MV is still there. Somehow half the kinetic energy is gone. And they just say a word like deformation or sparks or heat. They say it, but there's no evidence of it. And if it had happened, they're basically saying I could knock a piece off and I don't have to use any of the energy of those 2 objects. I don't have to use any of their momentum. So they're basically saying I can push something in space and the thing I push with doesn't have to have momentum. Because we know it's going to use its momentum to push it. It's just disgusting.
The true physics, of course, has to explain where the energy's gone, and that's why the kinetic energy formula correctly tells you that the energy, half the energy or whatever, has been lost in accelerating this mass. The energy's now missing.
So that's not what they say. So he can't even get their story right. They certainly don't say half the energy is lost accelerating the mass. All right, they never say that. So he's not even getting their physics correct, because they know it's an exchange of momentum. Okay, so they know they have to come up with some other reason than half the energy was lost accelerating the mass. No, there's no energy lost accelerating the mass, because the mass is still part of the thing you're measuring. The thing you're measuring already has its energy because it's measuring it. It's in the measurement. So how could I lose something that's still included? How could it be lost if it's going exactly with the thing I'm measuring? I mean, how could I have lost it if it's still going exactly in the same direction?
But your 10 momentum's coming in, 10 units of energy coming in, 10 momentum going out, 10 units of energy going out. There's no loss in energy, and yet we've accelerated this mass to the right for free, and you can't...
Okay, so there's no for free. All you've done is do a simple momentum exchange. You've exchanged a velocity, okay, for mass, and the two things are equal. The two things make an equal contribution to something's momentum. And so momentum is perfectly conserved, and it makes perfect sense because there's no obvious destroyer of the momentum. There's nothing that is actually making an arrow in the wrong direction. There is no force against. There is no leaking of the force. There is no something flying off in the wrong direction crap. None of that happened, and that's why all of the momentum was conserved, because you didn't change the direction of the energy at all.
Accelerate a mass changing its direction for nothing.
It's just about, energy is about, look, you just make something bigger and bigger and bigger. There's no complication to it. By his theory, what, I was supposed to explain all the energy losses of a Newton's cradle? No. So if I change the mass of something, then yes, the velocity is spread thinner, exactly as it took place. That's exactly what happened. I increased the mass and I just reduced the velocity proportionally.
You must recognize that's magic thinking, and it destroys your argument completely.
Oh, okay, so he says this is a destruction of my argument completely. There's no making sense of anything these fucktards do. What the fuck is Inmendum doing in the title? And Gary, I mean, frankly, I don't, my channel is Draft Science. There, you have it right there. What are these extra shit pieces for?
Now, have you got anything? Have you got anything?
Okay, so you're not defending conventional physics theory, okay? Their theory is that there's a lot of deformation and heat and chips flew off and all kinds of crap happened. So you're saying, no, they are wrong, okay? We don't need to have any of that happen, because we can claim that when we add mass to an object, it can't share its velocity over the new object and reduce its velocity, which is exactly what happens, and still have the same energy because it didn't change the direction it's going in. Just too silly. Anyway.
To say, yes, I'm wrong. Please.
Oh, go fuck yourself. Yeah, just too pathetic. Alright. So, let's see see if he's posted some other crap, and then we'll go back and look at that. So I don't know where he has this new video he's showing, with this little scale. It's not here in his uploads. Let's see. Nope, not here either. Interesting. Alright, let's go back.
In the interest of fairness, I wanted to correct...
Fairness. Fairness. Oh, what a joke. So what video is this? We'll see what date it's from.
In the last video...
Oh, the stupid, moronic, fucking treadmill thing. No, we're not going back and redoing his treadmill crap. Too silly. Okay. No change in friction force with increased speed and velocity of rubbing. Too silly. Alright. So this was like 2 months ago. Too silly.
In the interest of fairness, I wanted to correct.
I mean, he thinks it's the same thing. Putting something on top of a treadmill that's doing the turning force, that has the motion, and it's run by a motor, is the same thing as friction on, say, a rolling ball. Not the same thing at all. Alright, so let's see if there's any comments on this hunk of shit. He won't concede anything. So these assholes think this is a good argument. So should I just replay the physics girl argument next to his? And then you can see that, well, she was talking about deformation. How come you're talking about like somehow it should have to use up its energy to move the object, when no, the argument is that what happened was it increased the mass and decreased the velocity, and that conserves the momentum. So it's the force is still in the object. It gave force to the object, became one object moving, so all the force is still there. Well, you concede all the force that it started with is still there. It doesn't lose any force if the thing it gave the energy to is attached to it. How could it lose the force, right? I mean, the original thing has the force. You're attaching something. It still has all of its force. So why shouldn't it be just fine? Momentum's conserved. The force is conserved. See, when you put the word E, you could have used the word F. So all of the force is conserved. Let's see, he has just hand-waved away yours. Whatever that means. Despars in my recent efforts. Well, what do you expect, right? And where did you wave away the clay experiment he's hiding from you? Now, you can imagine it because you saw the original experiment where he had the numbers wrong. So you know how the experiment was done. So why don't you explain why it could be completely off? Like way off. Monstrously off. So you drop a weight on the clay and it's your job, and it compresses it like half as much. And it does it for both things. Your job is to explain that one. Have you done that, Mikkel? No, you haven't. Let's see. My drop test, he said, it proves him right. Well, it proves me right in the sense that why are you bothering with this obscure measurement? Why don't you just actually measure how much the spring compresses? In your case, yeah, it compresses. Okay, when I showed the half mass compresses the spring more. So again, more what? More consistent with kinetic energy? Did it come out right? No. So let's see, your spring wheel test shows roughly 4 times the energy. So 3.3 3¾ is the same as 5. Oh, okay. Another believer. Okay. So anyway, won't even bother. All right. So the most pathetic of the liars. What is this image he has? He thinks he's a samurai. Okay. I need a whiteboard and massive symbols and arrows to explain it to her. So what is this about again? I guess these are all chauvinists. They think it's to be called a her is to be called a weak and irrelevant. This is too rational for her to understand. So, I mean, what is this exactly? This is their, they're so butch. Oh, yeah, these guys are all so butch. I'll call them the butchies. Oh, okay. They're just so butchy. Oh, it's just so pathetic. Does it make sense what I am saying? So what is question mark? Does it make sense for you to contrive nonsense that isn't even consistent? I mean, you could have just made physics girl's example. You could have shown a tomato getting smashed by a bullet. You could have shown some deformation. You could have shown some sparks, and you could have shown some kind of bullshit. Okay, but instead you decide to make up absolute babble. All right, let's see. I work 9-hour shifts at what? The paper cup factory? Really tired, but it seems to make sense. You're saying you can't move an object without sacrificing some portion of It's energy motion, even if you're going in exactly the same direction and you're attached to the object. I mean, this is like just saying if I attach a steel ball to your ankle, okay, criminal, and you have to drag it around with you, you know, that somehow the energy you give the ball isn't going to be exactly in your direction, and nothing much is going to change in the sense that the ball is going with you. And if we throw both of you on a ship or something, the ball will be going with you. All right. To friction, wear, and other types of drag. So this doesn't even make any sense. What would drag have to do with any of this? Oh, I mean, this is so dumb that you're almost saying, "Oh fuck, there's no way that you can't even have a This experiment has been gone over so many times. Look, the real question is you're saying you can cause a bunch of heat or loss in a system, but you don't have to use any of the system's momentum. No thing with momentum has to create that new energy. That's your arguments. 10e moving, ke final when the object has a mass of 2 and a velocity of 5. Yeah, the same amount of total momentum. I'm almost thinking Merker is that weird Walker fucker. I mean, he's the one that does the her thing, right? So this is a sock account for that Walker weirdo? I mean, this is Walker weirdo kind of stuff. I don't know. Too weird. All right. Let's see. You're saying E1 equals 10. M1 equals 1. What sense? He's not making an argument that anything has changed in the scenario at all. He's just making some wacky excuse that somehow the other 5 tons that I attached to the object isn't still going in exactly the same direction as the other 5 tons. So how could I lose the energy if it's attached to me? If there's 2 runners and they're going to hand off the baton and it's got glue on it, they're both stuck together. Yeah. They've now increased, their mass, and their momentum is going in the same direction. Let's see. No, sorry, mate. Props. Pick this up when you're rested. To me, this is a simple nail in the coffin for his momentum energy argument. Amazing. I mean, I just have to, yeah, I have to preserve that. So he thinks this explains how they lose half the kinetic energy. They just combined 2 things and they lost half the kinetic energy. And yet all of the momentum is still conserved. So no momentum was lost, yet there is something else moving in the universe that didn't require something else's momentum. I mean, this is a Newton's cradle where both objects fly off. There's just no hope for this planet. So he made it clear. He's a great defender of the human brains that are contriving this slop. Okay, we don't need any maths. He says MV, or energy, is conserved by dropping 1 mass on a 1 mass going 10V. Yes, that's right. Making 2 mass going 5V. Yes, the energy was conserved. The momentum. You must have seen that he always uses this example. See, they're pretending now they... What's this? There's no point. Starting energy is 10 units. So I don't know even what they're going back and forth about. Okay, wouldn't technically energy conservation still hold if we consider the entire system and the Earth? Somehow the Earth. Okay, so the Earth ate the rest of the energy. It ate the kinetic energy. They don't have any evidence that it did that, but they say it did. Even though the downward motion is created by gravity. So all the downward energy didn't cost the this way anything. Okay, I'm just wondering. So he's doing theory with the Gosling moron. All right, so he says 1m times 10v equals 10. And he says daft energy units. So he's created a daft energy unit. So you could just say, you know, you could be saying that, so Descartes was daft, okay, and Galileo was daft. Yeah, all right. Output 2m times 10v equals 10. Yes, you conserved the momentum. The momentum is basically the force times the mass. As Newton said, twice the velocity, twice the force. 3 times the velocity, 3 times the force. The same, forget KE is about his argument. The same, forget KE, this is about his argument. Why would you forget KE? Your argument is that somehow, if I do work on an object that's going in exactly the same direction I'm going, that somehow the work should disappear. Why would it? So he's not accounting for loss due to heat, friction. So this Merker guy knows what the real argument is. Yes, I'm saying there is absolutely no evidence of any of that. There's no evidence of any of this loss of energy to any significant amount of any of those things, because all of those things, friction, sound, breaking, cracking, denting, all consume momentum. So if we make the thing out of crushable materials, you'll see that there's not going to be a significant amount of crushing, because all of the momentum has to be conserved. And all of the crushing this way, the crushing of the contact, happens because you drop the object. So if we connect the trains this way, and we make the trains out of soft stuff, the idea is that all you can lose is that little bit of momentum in the outcome. And they're, like I said, they've already conceded that you can make these things connect to each other very efficiently. Professor Lewin has done the experiment. I mean, come on, get real, please. With a piece of Velcro. And he's gotten, whatever, 97% of the momentum is conserved. So, yes, the crushing event consumes 3% of the energy. 3%. Not 50%. Alright. Forget all losses, as they say in the video, but where has the energy come from to accelerate the dropped mass to the right? So there's just no hope. The energy's still there, retard. It's stuck to the object. Obviously, I didn't give it away if I gave it to somebody who's in my own house. Or I give somebody in my own house $10. The money's still in my house. Why would I be concerned? Oh, I lost the money. No, I didn't lose it. It's right here. I mean, I could put it in my left hand from my right hand. All right, I have 2 $5 bills. Okay, I put one of the $5 in my right hand. Am I now poorer? Of course not. All right, that's probably the best way to dispose of this absolute contrivance of nonsense. Ugh, disgusting. What creatures. Alright, so I'll take a pause and see if there's anything else about that's at all relevant. There doesn't appear to be anything to report on. It's probably enough of a video anyway for such a simple argument. But whatever. Till the next time and such. I don't know, I just want to add some more analogies, just because it just seems like people should be able to get this. I mean, what they're saying. I mean, they're saying I can have two things with the same momentum. So I could have a 200-pound guy. I probably should represent that as this is the 100-pound guy and this is 200. So just pretend these two pens are the same thickness as this. So it's two of them. So I have a 200-pound person and a 100-pound person. And they're basically saying if I can make this 100-pound guy go twice as fast as these 100s, so they have the same momentum, that this one will be able to compress a spring more than this one. That somehow, even though they have the same momentums, this one's going to do more work. And 4 times. You know, that even if he compresses a spring twice as much, it's really 4 times the energy. Can that make sense to you? Because it can't make sense to me. Anyway. Till the next time, and such, and so forth and whatnot.